Okay, so starting with a water and lava planetoid, we're going to drop some small balls of sodium into the water. Sodium and water react to produce sodium hydroxide and hydrogen gas. Because it's exothermic, there's also a bit of steam produced. Some of the later balls will start reacting while they're still in the air because they're coming into contact with the steam. I'm currently not modeling the Coulomb explosion phenomenon, so maybe it is a bit more peaceful than it would be in the real world. Maybe in future updates the accuracy for this will be improved. In my second experiment, I'm starting with a water planetoid covered with oxygen. This time you'll see some sustained reactions in the atmosphere as well, since the hot hydrogen produced from the sodium-water reaction starts reacting with the oxygen in the atmosphere. Again, this reaction is probably slower and more peaceful than it would happen in the real world. One really surprising thing was when I decided to launch an iron ball into the planet, and that created a shock wave in the atmosphere, and on the front of the shock wave, the reaction between the hydrogen and oxygen was accelerated. I still don't have actual compression heating or frictional heating, but it was kind of cool to see that this was able to kind of reproduce something like that even without it. And lastly, in order to get this update working well, I needed to implement particle merging and splitting because of how sometimes very dense materials can react to produce very gas-like or sparse materials. So sometimes different materials need different amounts of particles to represent them well. And a nice side effect of getting the particle merging in is that black holes no longer impose a significant performance penalty. Before, once a black hole would appear, the frame rate would drop and it'd just be all kind of slow. But now you can even have multiple black holes even orbiting each other with basically no performance penalty. And so I'll end this video with a longer clip, just me messing around with some multiple black holes. And yeah, thanks for watching.